Welcome to part one of our coverage of key transforming operators in Project Reactor's Flux class. Transforming operators can be used to transform the values and/or the types that are emitted by a flux. And we'll be talking here about the map and mapNotNull operators. We'll start with the map operator. The map operator can be used to transform the items that are emitted by a flux. It applies a synchronous function called a mapper to transform each item. The map operator can terminate if the mapper throws an exception. Assuming no exception occurs, of course, it'll return a transformed flux. An interesting thing to note about the map operator is that the number of output items must match the number of input items. In other words, there's always a one-to-one mapping between input and output. Keep that in mind when we talk later about the flat map operator, because things are a little different. Here's a little code snippet we'll take a look at when we get to the case study at the end of this lesson. This code snippet takes a big fraction list and uses the from iterable factor method operator to turn that into a flux stream, and then it applies the map transforming operator to multiply each fraction in the stream by a big reduced fraction. Keep in mind again that map can transform the type and or the value of the elements that it processes. In the example we just looked at here, we're only transforming the value, not the type. RxJava has an observable class whose map operator works essentially the same as it does in Project Reactor's Flux class. Once again, you can see here, we take a list of big fractions, use observables from iterable factor method operator to create an observable stream, and then we apply the map transforming operator to multiply each of the fractions by a big reduced fraction. Both map operators in RxJava and Project Reactor are very similar to the map operation defined in Java Streams and its Streams interface. As you can see here, we have a little example where we take a list of strings A, B, and C, convert that list into a stream, a Java stream that is, and then we apply the Java map operation to uppercase each of those elements in the stream, and we finally collect that into a list and store it back in a variable. Let's now turn our attention to the mapNotNull operator. Like map, this transforms the items that are emitted by a flux. Like map, it applies a synchronous mapper function to transform each item. However, the difference here is the mapper function may actually produce null values, like the null keyword in Java. These null values will not be emitted. They'll be ignored. So mapNotNull, as the name implies, ignores values that are null. In a sense, it behaves a little bit like map of some function followed by filter of a predicate where we can filter out nulls. However, note that null is actually not a supported value, so it can't be filtered out. So if you want to filter out nulls, you need to use mapNotNull instead of applying map followed by filter. As with map, mapNotNull can terminate if the mapper happens to throw an exception. Otherwise, it will return a transformed flux that will emit no null values at all. As with map, the number of output items must match the number of input items. Here's an example we'll take a look at in the case study at the end of this lesson. In this particular example, we create a flux stream consisting of a couple of big fractions. The first will have the numerator 100 with a denominator of 3. The second will have a numerator of 100 with a denominator of 10, which obviously equates to the value 10 because 100 divided by 10 is 10. We then go ahead and use mapNotNull, and we do a little fancy ternary operator magic where we check to see if each of the big fractions equals the value 10, the big fraction of 10. And if it does, we return null. Otherwise, we return the big fraction. Because in the case where we have 100 divided by 10 being 10, null will be returned. But because we're using mapNotNull, that will be ignored. So the value null will not be emitted. It'll only emit the big fraction of 100 over 3. As with map, mapNotNull can transform the type and or the value of the elements that it processes. Interestingly enough, RxJava's observable class lacks a mapNotNull operator. So if you want to get sort of the same effect, there's a couple of things you can do. You can use Java optional, as we're showing in this particular example, where we're going to basically take some URLs and be able to download things from a URL. And then in this particular case, we're going to take the result of the download method, and if it returns a null, we're going to put it into an optional of nullable, so make it an optional using the of nullable factor method operator. And then we're going to only allow things to go through the continued processing if there is indeed a non-empty optional. and then we'll get the value. So this is one way to handle null values in RxJava. Another way to do it is to use something called transformers. Here's a transformer method that we might write. As you can see in this particular case, we're going to take a mapper, and if we end up getting a null back after we apply the mapper to the item, then if the result is null, then we're going to return an empty observable. Otherwise, we're just going to return the observable by using just. You can take this transformer method and apply the compose operator, which is a clever way of being able to extend the capabilities that are provided in an observable stream in RxJava. So in this particular case, we could do what we did before. Instead of using optional, instead we could use compose with our mapNotNull transformer method. So that's the end of part one of our discussion of key transforming operators in the Flux class in Project Reactor.